I'm working at PSNC, and I'm responsible for AI4EOSC project impact and communication. It's my real pleasure to host you all here on the webinar that is first of the series. We will have we have already announced 3 workshops, and those 3 workshops. So first is taking place today, and then the second one that we would like already today to invite you is at April 8th on the image processing with AI4EOSC. So basically, taking this opportunity, we would like to make 2 further announcements. So last days we have already announced the first release of the AI4EOSC, that is the toolbox for developing and running artificial intelligence models in European Open Science Cloud. And another important announcement is that basically just today we are announcing also open call for new users. So please take part in our webinar today, and I think after the webinar, I think you would be very interested in considering applying for this call. So you can scan this QR code and go directly to the web page where all is being described, and also you can apply there via form. So basically, I'm today with my colleagues here, and the webinar is organized, as I said, by AI4EOSC project, but also in collaboration with other projects in EOSC and in AI ecosystem. So here today we have few of the colleagues, and the main organization part body is here the project coordinator Alvaro Lopez, and also we have with us today Judith, that will be moderating together with us the session. So we have now basically 4 of the talks today, and so without further delay, I would like to invite Professor Gwen, that is a senior researcher of the Institute of Informatics of the Slovak Academy of Sciences. And her research basically include topics like machine learning, deep learning, privacy and security, with the high performance and distributed computing backgrounds. She is also an associate professor in computer science of the Faculty of Informatics and Information Technologies of the Slovak University of Technology in Bratislava, with the courses Introduction to Data Science. So thank you for this, and we start now the series. So please, Professor Gwen, please share your screen, and the floor is yours.
Okay, thank you for invitation for the talk, and I will. Do you see my screen? Yeah.
Yes, please go on.
Okay, I can go, and we will be with my talk about general introduction to artificial intelligence and machine learning. It is a very exciting. Okay, some. Oh, sorry. Okay, the first thing that is a very exercise area about artificial intelligence and machine learning, and everyone knows that machine learning has a a lot of application in every areas. everyone say that machine learning can be seen from the three main areas: unsupervised learning, supervised learning, and reinforcement learning. Every these areas is quite okay. I have some problem with this. The usage of artificial intelligence you can see now in every areas, in the politics, in government, or in banking, in transportation, and education, communication, and anything else. You can see here a very unclear image that is from the 2022-23 machine learning, AI, and data landscape. This image is done by Method, that is the enterprise from the America. And he did this for several years. And the thing is that his image is from years to year not so clear. And in the last year, he said he must use a modern technology like interactive, visual, and some website, and you can click on every box, and you can see the bigger picture. From this picture, I just want to see a very short vision about what happened in the last year in the machine learning, artificial intelligence, and data that meant exponential acceleration of generative AI with ChatGPT is a very typical example. Also, we have here some problem is artificial intelligence because it's a generated content is biased and has some hallucination and is leads to the responsible AI. I will say about responsible AI a bit later. About big data and Hadoop, it looks like it's gradually disappearance, but it still active. And we have some crypto and Web3 analytic and data mesh, product contract, and so on. To go about the next, just for the interesting thing that in the 2021, that is the previous one version of the Matuk landscape, the picture is a bit clearer. But however, it shows that the trend in artificial intelligence and machine learning and data is constantly growing, and it is in every areas of our life. The public imagination about artificial intelligence is the core is the machine learning and the data. It that you just put the data into the AI and then some black box, and we have some insight and with some increasing income in a very short time. But in the real, you can see that the state is much more complicated. We have a lot of data flow, machine learning flow, and some data stream, and some illustration, and then you have data pipeline, you have the REM machine learning model. That is a very complicated process. Also, we have a lot of machine learning methods. The number of the methods are quite high, and it is increasing by year and year, and that is not very clear that each method is suitable for our solution and so on. And with the machine learning method, we also had a lot of problems with dataset. The first one is the imbalanced dataset. Then you have to do some technique to deal with it, like undersampling and oversampling. It looks like very easier, but with the undersampling, we have the problem how to make the data typically for our problem solution. With oversampling, it is much more easier at the first sight that you just copy the minority class, let's say, advertise, but we have problem with this if you have a lot of data. Then when you oversampling is, you have bigger and bigger data, and is no good too. With machine learning, it not running for you automatically because the model, if you do it at the first step, it will not be the optimal model, and it might not work with your data. Then you have to do it some technique to improve the performance of the model, like feature selection, model training, hyperparameter tuning, and the other technique. The way how you can do it, that I believe that with all of the technique, we will have the optimized machine learning model, and it will help us to make the better decision in the uncertain world of a lot of things. Yeah. And the optimization technique, I will say briefly that you have assumptions like research, random search, Bayesian optimization for deep learning model, and it is a very computational expensive. And again, with the neural network and the deep learning model itself, you do it a gradient descent optimization technique, and we also have some nature inspired method when you and we have a lot of high computational method. Then this method will help us to deal with a lot of things. Okay, the amount of data is increasingly increasing from year to year, and I will show you in a very briefly way how is the evolution. At the beginning, when you deal with big data, you have some HPC cluster and some computer-intensive application. These clusters are amazing, but the architecture is not very suitable for data-intensive application. Then to generate it, we had the Hadoop cluster that in a bit different direction in comparison with the HPC architecture. After that, about nearly 20 years ago, we have a very, very long way to go with the Hadoop architecture. And at the end, then we have some problem with it. The problem is that the rise of deep learning and the need of GPU, and they are not in the Hadoop cluster. Then currently, the current shift is from Hadoop ecosystem to cloud services like Kubernetes, and the reason is the rise of deep learning and the downfall of Hadoop system. And then you see everyone say about NVIDIA, Graphica, accelerator, and so on. Yeah, and deep learning. And that is a very exciting word also for everyone of us. However, it is started from 1940 and so on. And we have the first one neural network, and then you have some deep neural network. And in the first success is the hand-written digit recognition internet. And since 2029, the deep learning success is the belief is to be done because of the three factors, that you have a new algorithmic advances that with better performance, and you have the ability of a huge amount of data to train these neural networks. And the last and the very important thing, that the increase of the computing power. We can mention here that the Stanford Vision Lab from the Stanford University and the Princeton University with the ImageNet large-scale visual recognition challenger, which contributes to the evolution of deep learning in this current state today. Other factor to involved with machine learning, neural network, and deep learning also is the existence of the already very, very nice framework, let's say scikit-learn for machine learning, and for neural network and deep learning, TensorFlow and Keras. It has more than 50% in production, and PyTorch with nearly 45 or 48% in the research. That means a very exciting framework that give us some easier access to the exciting world of machine learning neural networks and deep learning implementation. I can go briefly about some the most of the architecture of deep learning that the most I know everyone know is the convolutional neural network or CNN. About this one, everyone to know how we can make some architecture by our own knowledge. That is a very harsh question. However, the window pattern is some input layer and some convolutional layer, mark pooling, and convolutional layer and mark pooling, and some full connected output inward. However, it is not so easy. And we have a lot of economic CNN architecture like LearnNet, AlexNet, VGG, Google LearnNet, ResNet, and Squeezelet, and currently the number is very high, and they are also already in a lot of library as deep learning application. The CNN contributes a lot about the advance of the computer vision at the moment, like object detection, facial recognition, and so on. They are very exciting. I think everyone want to have the iPhone is facial recognition to unlock your mobile, and everyone is saying about the yellow. That meant to detect an object in a picture and so on. However, with this technology, we also have some bias and some problem with this, starting in the year 2020. That made the problem, let's say the black man problem, that meant America first confirmed wrong arrest by facial recognition technology. And also in the same year, that is the problem with data. The Clearview AI, small company in America, also graph some billion picture from the social media. Yeah, I know here we can say that that is our fault to put it our own personal data in the social media. Yes, that is some problem. Then. In this direction, we have image segmentation. It's a very, very exciting also direction. And in this one, you can have the two main things, the semantic segmentation and instance segmentation that have the localization and classification some object in the image. That is very exciting too. And here we also have two directions. The first one is the classic one, which is less computational expensive, but everyone want to do the deep learning one with the typical architecture like UNet, OMAS, CNN, and the last one is the MetaSum segment anything model. Yeah, that it look like very exciting, but someone say it may not work very well for everything, but the progress is coming. Okay, and yellow is also very, very interesting areas because if you see about it, and then you see that the author George Redmond say that he stopped his research on yellow because he has some concern about ethical problem in artificial intelligence and computer vision and concurrently with his technology. However, his colleague and other one continue in this progress as well. I think currently the yellow has the version of 10 already, not 8 like in this picture. Then the second architecture that we had the CNN, and now we go to the recurrent neural network, encoder, decoder, and natural language processing. Here is also a very exercise, very, very interesting areas of deep learning. which allows pre-trained model for natural language processing, is the most notable library is the SPACY. The natural language processing is also go through a very long way to have everything in this stage now. It go through not deep learning method, like classic one with machine learning or statistical and anything, and with text processing and so on. But the last one is, of course, distributional semantic and contextual representation with deep learning, and with the most typical deep learning architecture, let's say transformer. Yeah, and these areas is booming. With sentiment analysis, question answering, text summarization, translation, and so on, and is also go to natural language understanding. Because natural language understanding is a bit different from natural language processing. Yeah, and of course, recommender system is a recommendation with the AI assisted technology in background. Everything is very exciting, and we see a lot of things is already in the production, like ChatGPT and so on. And that means this model is not just only in the laboratorium, but they are also in some real production mode. That means model deployment and curation. Model deployment and curation, that is a big problem. Because till the last year, we say that model deployment, 87% have never been. Oh, that is a quite high number. However, 2 years and 4 years ago, the number is much more smaller, and the state is going up and rapidly. Okay, and everything is very nice, and every hash with the training model make it optimized and make it running as we want. But the deploying of the new model is just the beginning of a lot of things. You can see that it's very also hard work, because you have every code in the GitHub, and after that you have to automate a lot of things with the dev of technology. However, DevOps is not designed for machine learning. Then we have machine learning option and data option. That means faster DevOps is a faster software delivery and some software quality assurance. And machine learning option is the kind of DevOps applied to machine learning operation. That is exciting, but it is a very complicated area, because instead of just 2 cycle, we have now 3 cycles. That is hard work for engineering and IA practitioner. Also, data is not stable, like we decide. Because in the rainbow scenario, data is always changing, and from the machine learning view of point, when the change of data distribution is called data drift, and data drift, that means problem, because the model may not work when the data is somehow changed. That means we have concept drift, or other name is the model drift. That means the degradation of our machine model performance in the production. That means that is to the very heavy work of machine learning in DevOps and machine learning option. Yes, generative AI is ChatGPT. However, generative AI and ChatGPT is not the only what we say or we think about the artificial intelligence, but is in the center of attention of everyone. And I will go briefly through it. The first one is the natural language processing transformer since the year 2017. And it's a very nice paper with the name Attention It on Unit. Yeah. And the architecture is the autoencoder architecture, autoencoder decoder architecture. That means we have CNN, bottom INN, and now we have encoder and decoder architecture. The transformer has also the benefit and the drawback. The architecture is the encoder and decoder is highly parallelizable. That means we can run it in parallel, which significantly speed up the training and the inference. And it can capture long-term dependencies in text and make it a better understand for human. But the architecture is a high computational demand. And it is sensitive to the quality and the quantity of the training data. Then after the transformer, we have also a lot of large language model like BER, GPT-2, XLNet, and Roberta, Albert, TP5, and GPT. And GPT now is a lot of version. The reason for a lot of large language model is that we need sometimes some customization for some problems. Sometimes we need to more robust, and sometimes we need to run faster, and sometimes we need to be better in some domain. Alone it shorter. Then that is the reason that we have a lot of so expensive large language model. In computer vision, the transformer is also attacked to these areas by vision transformer, and the vision transformer apply the techniques here from the natural language processing transformer into the computer vision problem, and it is also a very computational demand architecture. When you compare the vision transformer with the classical CNN architecture, and you want to know if it is better or it is not better, then the reason is currently say that it is a very promising, but it is not clear the winner. The vision transformer is the iconic CNN architecture. However, it is a good try because we have a lot of data and a lot of domain areas. In the large multimodal model, that means we combine more data into one model is also very exciting. We have image generation, auto generation, and some search engine and code generation, and so on. Now, then everything is still not working. That is not new in artificial intelligence areas. We have already history in 2016 and 2022, and that is quite normal. Let's say not very normal, but some frequent in artificial intelligence development and development. The Galactica, yes, that's the model that can write some scientific paper. It is so down, yeah, but it is not very working for us. Then a lot of people is asking about artificial intelligence and ethics problem. Something is working, and sometimes, for example, ChatGPT from the OpenAI and so on, with a very impressive result. However, it still has some issues and so on. I will go briefly through this part that ChatGPT is still not very reliable interpreter of the words. A lot of people think artificial intelligence is a kind of something you can rely on it, but it still not in this stage. And the model represents some security and some uncontrollability problem, including the false content and some biased information during the content generation. But however, it not meant that we cannot use them. It is using. It is applying and a lot of people like it, and we are using it and so on. Yeah, and that is the example how it is ChatGPT or GPT is for it the best and the worst example for artificial intelligence today. And we have a lot of problem to generate and a long way to go with artificial intelligence. In short, all of these large language model and large multi model have a very high performance requirement. It requires a multiple GPU, which we are training several months to have some model, and the energy cost of this model is quite high, several €100,000 or USA per month, and several months. Yeah, and you can see each of these model as a piece made from the long time high energy consumption. And we have to deal with bias, inconsistency, and ethical concern of a lot of people, which leads to responsible AI, as I showed at the beginning. Yeah, and here is several aspects in the responsible AI that remain the only way to mitigate the AI risk. The core of the responsible artificial intelligence is the trustworthy artificial intelligence. That is the methodology to implementation of artificial intelligence method in a real organization with fairness, modern explainability, and accountability in its core. The purpose of all of this is you want the artificial intelligence to help people, but of course we do not want to replace human at all in the world. Yeah, and with artificial intelligence we are going in the way, let's say, human-centric artificial intelligence. As it is started in the European Union guideline for ethics and artificial intelligence context and implementation. From the one side, we had decided to be ethics and to be anything. On the other hand, we have also a lot of regulation today. The first one is the GDPR. And the second one is the DSA. DSA is the new Regulation on Digital Service Act from the 2022. And on is about personal data, our personal data, that we have to deal with this somehow. Okay, and we have to preserve our privacy in the process of data mining. We also had a technological way to deal with it. The simplest one is data transformation with pseudo-anonymization, difference and privacy. After that, you can ensure the computation to be secure by hashing, encryption, or homomorphic encryption. And you can run our computation in some trusted environment like specialized hardware, some secure execution environment, or confidential computing, and so on. It is very in the center of attention of us about data protection, and so on, because we want to collaborate with each other. and that means federated learning. Centralized learning, that means I have all of my data in one center, and I have a problem with access right and owner right and who can see my data and so on, and a lot of concern about it. And distributed learning have to solve with this problem, that the data do not have to leave the original organization. Then we have federated learning. Yeah, and I will stop my presentation here, and we are opening the door to the very exciting areas with our project artificial intelligence for EOSC with federated learning as its core. Yeah, and thank you for your attention. I will finish my very long talk here, and that is all. And thank you.
Okay, thank you very much, Professor Gwen. That was a very interesting talk. So why we would basically wait for the questions from chat, because we are looking from the audience to post the questions to each of the talks. My first question is there any way to ensure the privacy of our data when using artificial intelligence applications?
Yes. Maybe I will sharing is again that we have a lot of way to ensure the privacy in data mining. Just, yeah. I will go to the we have at least three ways. Three, I say, big way to deal with privacy in our system, and that's a bit. Oh, here, yeah. The very easy thing is the data transformation. That means you have to clean our data from the source. When you have some personal data in our side, and you want to make it a collaborative model, which can be used also by other users from other organization, then you have to clean it at the first way. Yeah, that means some anonymization technique, and we use some difference on privacy. Difference on privacy is the let's say mathematical approach that we put some noisy into our data to make it undetectable for the attacker, which can be in the middle way of the distributed learning. In this way, the attacker cannot know from which source is our data, and this is the way to protect the privacy. The more secure way is the computation. Then you have the harder technique, stronger technique that may hashing that, like you can connect to some server using your password-based encryption. Which is symmetric or asymmetric. Yeah, and in this way, when you want to make our model in a very safe way, you have homomorphic encryption, which can be fully or partially. Why here is fully or partially? Because homomorphic encryption is a very computational demanded. If you have fully encryption in this way, the computational demand can be go very high, because in every step you will increase the computational requirement to decrypt or come back to the previous step. In the practical way today, we are using more partially homomorphic encryption because of the computational demand of the technology is so high. Yeah. And the last one is the trusted environment, that you have some specialized hardware, which is a very expensive hardware too. The secure execution environment can be ensured by hardware way or by the software way. And in the cloud computing, the very modern technology go with the confidential computing.
Okay, thank you. Thank you for replying for these questions. So I'm seeing comments about here on what AI4EOSC should do for public sector, but this will be addressed, I think, in the next following talk by Dr. Alvaro Lopez Garcia. So I think as this will be answered there. I'm coming to next question. So basically, you were mentioning the NLP transformers that are computationally demanding. So what are the alternatives can we use instead?
Yes, all of these large language model or large multimodal model are very computational requirement, have very high demand on it. It leads to financial demand too, and it is a big problem, and it is also lead to environmental problem. If everyone want to train the large language model like transformer and so on, I think the way is to reduce this model like piece of knowledge and technology, which is done, and we have a lot of piece of knowledge at some store. And you want to reduce this into some domain-specific domain or problem, you have to customize this in the way of transfer learning or fine-tuning this model. The next solution is to quantization of this model to be less accuracy. Yes, currently the way is to go through 4-bit quantization or so on that makes the model smaller at some cost of the accuracy of the model, but it can solve the problem. Of course, other techniques like statistical or machine learning exist, and it is for us to consider which technology is suitable for our problem. If it must be the deep learning model like transformer, or it can be some cheaper with less satisfied result, then it can go by this way.
Okay, thank you very much. Thank you again for your very good presentation, very interesting. So we now will move to the next speaker, that is Dr. Alvaro Lopez Garcia. He is a CSIC tenured scientist at the Spanish National Research Council. He is the head of the Advanced Computing Science Group and the project coordinator of the AI4EOSC project. So Alvaro, welcome, and the floor is yours.
Hello, everybody. I hope you can see my screen.
Yes.
Okay. So thank you, Marcin, for introducing me, and thank you, Yang, for this very comprehensive and interesting presentation covering many hot topics that are currently ongoing. In this short presentation, I will briefly introduce you to what is the AI4EOSC project and our scope within the AI world and the European Open Science Cloud. First, I would like to just show a couple of slides of what the EOSC is about. The EOSC mission is to develop what it is called the Web of Fair Data and Services to enhance the access, reproducibility, and the digital transformation of science in Europe. In this context, it is worth mentioning that the EOSC is not a cloud provider or just a cloud infrastructure, and it will not own the data or services that are involved in the EOSC, but EOSC is the enabler that will allow us as scientists and research providers to work together. Why is this initiative being moved on? Because the European Commission has seen that we need to unlock the full potential of research and research data to accelerate discoveries and innovation. And nowadays, science is driven by data, and we needed to react about that. How is going to be done this? Well, first by ensuring that the open science practices that the EOSC is enforcing become the new normal, and that these practices and skills are rewarded, enabling the definition of standards and the development of tools, services that will allow researchers to find, reuse, access, combine results, fostering new discoveries. It will also do so by establishing a sustainable and federated infrastructure that will enable this open sharing and reuse of scientific results. And all of this is framed by the strategic research and innovation agenda. The EOS is evolving, currently moving to a stakeholder-oriented approach where we all share a common vision through a partnership. In a nutshell, EOS aims to support researchers by improving scientific research, fostering innovation, improving the transparency and reproducibility of research, reducing and breaking data silos, and facilitating interdisciplinary research. In this context, we are the AI4EOSC project. That is an action that started 1.5 years ago in September 2022. That is the evolution of our previous platform that was called the Deep Hybrid Data Cloud Platform. We are 10 partners in total, 7 academic, 2 small enterprises, and 1 non-profit organization. What we are doing here is developing advanced services that will allow to develop AI services exploiting distributed federated learning, composite learning in the EOSC. So all in all, we are a cutting-edge initiative that sits between AI development and the European Open Science Cloud, serving as an enabler for scientists. So what we provide is a user-friendly workbench and toolbox to develop AI models that is integrated with the EOSC resources, data repositories, authentication and authorization, accounting, and so on and so forth. We also have links with sister projects on the EOSC exchange, allowing us to consume data from other initiatives. But I would like to mention that we are not focused on developing new AI algorithms, but rather on helping researchers in the context of the European Open Science Cloud to build their AI models and applications and transforming them into services so they can be reused by a broader community. In this context, we are building a distributed and federated platform that is powered by an open source software stack that we call AI4OS. We have integrated different cloud providers from the pan-European research infrastructure like the EGI Federated Cloud. Here with the clouds that are in purple, we have the current ones that are serving the AI4EOSC platform, but in parallel, we are also contributing to the iMagine platform that is developing a customized version of our software stack focused on imaging applications. The idea is that we will facilitate access to researchers in Europe that are not keen on working with these low-level infrastructures, cloud infrastructures, via a feature-rich set of services that allows them to build AI models. And this is what we will show you in the next 2 presentations. This is our very high-level architecture. We basically are going to focus today on the user that is depicted here. This is a very technical picture, but we will show you how to interact with our development environment today and how you can browse, deploy, and manage the existing applications through the AI4EOSC dashboard. If you wish to dig more into the details, we have provided our architecture as an open document following the C4 model for visualizing our software architecture online in the QR code that you can see there in the right-hand side of my slide. So what we are doing, we are focusing on this AI and machine learning application development lifecycle. We took this from previous initiatives that we were working on, and when you are developing an AI application, we probably have some data that can be level or not. You may have a reference model that you want to fine-tune, or you may want to develop a model from scratch. So starting from the left-hand side, we are providing tools in order to consume existing models from a shared model repository or build models from scratch, allowing you to make the train testing and validation of your model within our platform until you can reach the desired accuracy of your model and you are satisfied with your model outcomes. Once this is true, we allow you to contribute back the model to this shared repository so that you can convert it into a service that can be served and can be monitored so that the functionality can be exploited by the different users. This is the timeline of the features that we are delivering. We are now between 2023 and 2024, so we now provide you with customized platform deployments for resource providers. The items that are depicted in greenish are the ones that are focused on final users and user scientists. So we allow you to do federated learning on the EOS, both within the platform and externally, also in your own resources. We provide interactive development environments on the cloud that are exploiting the resources coming from these pan-European infrastructures. We provide you with data science templates for your projects that can be created on the fly through web services. We provide fine-grained reports of what you have consumed. We are providing an experiment-centric dashboard that is continuously evolving, gathering requirements from the users. Deployment of AI models as services over cloud infrastructures, online annotation tools, machine learning operation pipelines, and drift detection, and a provenance model, comprehensive provenance model that will be delivered in the next months for machine learning applications, allowing us to enhance the reproducibility and the trustworthiness of AI systems. How we are doing this? Let me go briefly through one of this set of slides, because this will be much more in detail afterwards. We are building an open marketplace and dashboard that allows scientists to browse the models that are already integrated in the platform and to reuse them for their needs. All of this is online through the links that are at the bottom. And the good point is that even if you don't have access to the platform itself, you can download the models that are already there and reuse them on your own laptop or on any other compute infrastructure that you may have. Through this dashboard, once you get access to the platform, you get easy access to one-click deployment of development environments based on the most two common editors that exist at the moment, that is JupyterLab and Visual Studio Code. All of this, as I said, is executed transparently on the resources that we have integrated into the platform. Once you are developing there, you obviously need access to GPUs and to powerful resources. So we provide also with a transparent GPU access so that you don't need to bother configuring the GPU drivers and getting access to some of them. All of this can be done through your browser without worrying about. We are also not only providing this, let's say, execution environment and development environment for basic AI applications, but we are also delivering a tight integration of the currently most common federated learning system that is based on Flower, so that you can deploy a federated learning server, a set of clients in the platform, and also contribute with external clients to the training process of a federated learning AI application. For this, since we think that this is a very relevant feature of our infrastructure, and a very important step forward, allowing scientists in the EOS to exploit the functionalities and the easiness of training of Flower, that we have dedicated a webinar that will be held on the 22nd of April for this topic. We have partnered with the Flower developers in order to provide feedback of what we are doing and what we are developing and our needs, so that they can contribute and help us to streamline this tight integration, as I said. But we do not stop there on the development side. Once something is developed, we want to get the functionality, right? So we provide scientists with tools to serve and monitor their models as a service, so that you can convert an AI model into a full-fledged service that can be used for doing inferences and predictions. We allow you to deploy as a standalone service on a given cloud infrastructure if you have access to one, like AWS or Google Cloud Engine or the EGI federated cloud. We allow you to deploy this automatically to a serverless infrastructure and service codename Oscar. And we allow you to deploy a sandboxing environment for testing this inference within the platform itself. We are currently working on delivering this in the next weeks. We are also working on delivering composite AI tools, so different modules can be combined to provide more complex application using a visual interface again in the browser. And once this is deployed, we provide you with tools to do continuous integration, continuous delivery for this machine learning development, so that the modules can be automatically updated whenever there is a new version, and tools to provide comprehensive monitoring of the models that are developed there, providing you with tools for drift detection, like I will show you in the next slide. So this is deployment as a standalone service from one of the modules that are in the marketplace. You can just go with the infrastructure manager, which is another service that is part of AI4EOSC, and you can log in with your credentials, and you can deploy it on any cloud infrastructure, so you can get the results. This is a real resource from a use case that has been developed by the OPSI research infrastructure that is doing fish detection on underwater cameras via YOLO, a YOLO AI model. This is about the composite AI, so you can visually, for example, create this pipeline where you can get a video, extract the relevant frames that you want to classify, do some classification, and then, for example, do an ensemble modeling or just mean the probabilities of the prediction. We are also providing with tools for drift detection. We have implemented the state-of-the-art library for drift detection, which is codenamed Florus, allowing you to implement the most common data and concept drift algorithms right away with an API that is framework agnostic, so you can use it with any existing machine learning or AI framework. That's all from my side. I just want to remark that we have an open call for new use cases that will be run in the next weeks. So you can contribute, get access to the platform and help us in shaping the future of AI4EOSC if you apply and get selected. That's all for my side.
Thank you very much, Dr. Alvaro Lopez. So it was a very good presentation. So now we have some questions from chat. Going to the question, the EOS marketplace will stop in a few weeks. Do you have a roadmap for integrating into EOSC-EO node?
Yes, indeed. Since this the EU procurement was awarded in, if I'm not mistaken, January or at the end of 2023, we are aware of the new well, of the procurement, I mean, to the consortium that has been awarded, and the EOS Beyond project that is starting in this month. So we obviously integrated with the EOS marketplace because it was the tool that was in place some months ago, when we started working on the EOS integration. But we are aware of it, and we have a roadmap to be integrated with the EU node at all levels: monitoring, accounting, authentication, authorization infrastructure, and so on. Yes, we participate in the EOSC relevant task forces, working groups for this, and we are planning the next steps for the upcoming months. Yeah.
Okay, thank you. There was also a question from the previous session about if our project is addressing the challenges for the public research, such as using AI for quality control of data, making data fair, and similar.
Okay, as I said, we do not develop AI algorithms on ourselves, but we provided the tools for researchers to develop those algorithms. We are in contact with some existing initiatives at the moment, and well, future projects that might be awarded, that have partnered with us in order to work along these lines, especially on building assistance for fairness of data and for quality control of data. But this is ongoing work. As I said, it is not the core of our initiative. We want to develop tools so that scientists can develop applications, but obviously we are in contact with some initiatives that are working along these lines that I think are of paramount importance for the EOSC, and that need to be, those aspects need to be taken into account seriously. I mean, this has to be done carefully, ensuring that models are developed thoroughly, and because otherwise, well, they cannot be applied for any scientific endeavor, as we can see, for example, what's happening sometimes with these large language models that hallucinate or just provide fake or wrong information.
Okay, we have another question that I think also I will initially partially respond, and then I will let you, Alvaro, also say. So the question is, do you work with the Simple Consortium, which is developing the middleware for European data spaces, including EOSC? I would like just to give like pre-response that partners, some of the partners of AI4EOSC consortium are directly working with the architecture or design phases of some of the European data spaces. So we are kind of fully aware of what kind of interfaces, what kind of standards are being developed. But Alvaro, can you please follow up on this question?
Yes, I mean, I don't have much to add. We are aware of all of these initiatives, and when we have been developing our architecture, we have followed all the recommendations and blueprints that existed at the moment. We have developed this in a way that by following standards and engaging with the EOS interoperability framework and the EOS interoperability of data and services task force, the EOS focus project and the EOS association, well, with all the different stakeholders, we can ensure that if things change, we are able to change them quite easily, to interchange a given technology with another one. Although, since we have followed all the recommendations and standards that were currently well, I would not say enforced, but that were currently in place, I would say that we have streamlined the final integration of our platform and services into the EOSC EU node and the EOS data space as it will evolve over the next months.
Okay, thank you. Thank you again, Dr. Alvaro, for this presentation. Now we move to next speaker, that is the Ignacio Richa-Cacha, is a researcher at the Spanish National Research Council, developing tools to foster the adoption of AI in science. He's a member of AI4EOSC project, and he leads the Experiment Centering AI Services work package. So, Ignacio, please, the floor is yours.
So, hi everyone. I hope you can hear me and see my slides. So
yes, please continue.
Yep. Okay. So in this talk, I will give first an introduction to the AI4OS documentation. That is the documentation that goes through all the components in the project. Then I will introduce the dashboard, and once in the dashboard, I will show you how to make a simple inference, how to retrain a model connected to our storage, Nextcloud, and how to deploy a development environment. So let me go let's go to the demo. So this is the document, the AI4OS documentation. So you can find it in docs.ai4os.eu. And well, first of all, you will see that you have lots of useful links. So this goes from the homepage of the project, the documentation itself, links to specific important parts of the documentation, so the authentication, the dashboard. Then you will have links to our storage service, that is Nextcloud, the links to the software of the project, both the AI modules and the project components, like the dashboard. Then we provide links to the container registry where the AI modules are stored. And then you have more links, like well, how to check the status of each service in the project, links to the page for creating new AI modules, to the MLflow server that we have deployed for our project to track your trainings. Then you will have links to the inference platform that is powered by Oscar, and also to the workflow platform to compose AI workflows. So this more or less gathers every important web page you need to know about the project. So please check it out. And then once you are in the documentation, I suggest you start taking a look at the quick start, and basically then you should proceed taking an overview of the whole project, so you have a clearer picture on how the project is structured. So you can see how the architecture is set up. So what are the different components? So let's say the dashboard, the continuous integration workflow, and so on. What are the specific user roles? So, well, you are new to the project. So what do you want to do with the platform? Do you want to train a model? Do you want to make an inference, and so on? So depending on what is your intended usage of the platform, you will be guided through the documentation. Then we have a dedicated page for authentication. So this, of course, the resources the usage of the resources need an authentication, and for this we are using AGI check-in. So once you are approved in the project, you will be able to use your AGI check-in authentication to access all the platform resources. Then we go through how the modules are structured and how to create new modules. One key feature of the platform is the DPaaS API. So in order to provide a single entry point to all AI modules, we have developed an API that basically lets you do prediction and inference and training on any module in a standardized way in any module of the platform. And then this is what I will show you, the AI4OS dashboard, and then how the AI4OS storage works. So our next cloud storage. So to put a bit in context, how the three tutorials I'm going to perform in the dashboard, I'm going to showcase here in the how to what the three different tutorials, the different usage, mostly broadly speaking, the most three important ways in which you can use the platform. So first of all, a basic user would only just do inference on an AI module, so it can do inference with dashboard. So this is what we are going to see, or performing inference with Oscar or any of the AI workflow tools we have also integrated. Then an intermediate user would not just only do an inference with the dashboard, but possibly also retrain an existing model in the AI marketplace that we have. So this is what I'm going to also showcase. And then, well, again, with this retraining, he can sync his module training with our Nextcloud storage and use our MLflow server to track the trainings. And finally, an advanced user would not only want to do inference or retrain a model, but also develop a new model and possibly share it with other people in the platform. So this is what Borja will explain in the next talk. So I will leave this to him. So just to mention, we have also quite some frequently asked questions about the platform. A small guide on machine learning resources for those of you who are new to machine learning. And then we also have some video demos. Of course, the documentation is always more updated than the video demos, but in case you want some live explanations, you can also go there. So let me go to the dashboard. So this is what the AI4OS dashboard looks like. So as you can see in a public view where you are not logged in, what you will see is a marketplace of all the modules that we have integrated with the platform, and you can select any of those modules, and you will see the module information, the build status, the license of the module. You have links to either the dataset in which it was trained, the code of the module, the Docker files of the Docker container which powers the module, and then some broad categories in which this module fits. So this is the public view, but as I explained earlier, once we accept your application and you become part of the platform, you get an EGI check-in account with user rights to use the platform. So for this, once you log in with this EGI check-in, you can log into the dashboard and you will see an extended view of the dashboard. So as you can see, the difference lies here below. In this case, so you get a new tab, which is the AI deployments you made, and then you get these two buttons that allow you to deploy any of those modules either in your own cloud or in our platform. So, for example, if I went to deploy this image classifier, I can give here a random name, and then I would deploy it, for example, directly with the DPaaS API. And I can do, if I don't want to customize anything further, so I don't want custom resources, I can do a quick submit with this. And then you are redirected to the deployments page, and as you see, your deployment is starting, so it's running. So this running status means that the Docker container has been deployed, but sometimes the service inside it is still starting. So let's see if okay, the service just start. So in this image classifier, in this quick access endpoint, you will see the service you decided at the beginning. So to use. So as I said, we were using the DPaaS API, that is the common API to all models in the marketplace. So if you use this DPaaS API, you will see that you have those train methods and predict methods. So just this first part of the tutorial is just how to make a simple prediction. So let's go with this predict method. I'm going to upload a simple image of a lion, and then, well, you could customize something else. So choose other modules in the other models, well, other weights, or so on. But well, this is the default. So let's go with the default. So you see that the prediction was getting processed, and this is the response. So as you can see, just it's not really important for the purpose of the demo, but it did predicted a lion with 99% of probability. So well, we are happy, I guess. And well, this is, if you remember from our user roles, this is like the basic users. Basic user just takes a module and performs an inference. So let's go with the second user, the intermediate user. So the intermediate user is still more or less the same, but what he wants to do is not just make an inference, but retrain the model. So if he would go the same way, so just put in here a random, well, not random, you doing putting this information, the deployment title and so on. But now as he wants to train, he probably wants to customize the resources he's going to train on. So these are the defaults, but he can go up and down. So anything within the limits of what is offered is allowed. So probably if he wants to train, he also might want to have GPUs, and then he could potentially select a GPU. And then once you customize your hardware, you might, the last step would also be, if you want to train, you probably want to have access to your data. So instead of uploading it directly by hand via JupyterLab, what we provide is a direct connection to our Nextcloud storage. So what you do is this is the storage is located, well, as I said, you have links of everything in the documentation, but just for mentioning, share.services.ai4EOSC.eu. And again, once you authenticate with the project credentials, that is AGI check-in, you get access to our Nextcloud server, and then you can upload all the files you might want to access from your deployment. So for connecting your deployment to Nextcloud, what you have is to provide an Airclone user and an Airclone password. And in the documentation, we explain how to get this information. So use Airclone to sync your dataset. So here we explain how to get this information from Nextcloud. So as this is more overview tutorial, I'm going directly to proceed to an instance I have developed. I have already deployed. to make a training, and that is already connected with Nextcloud. So I'm going to same again quick access, but this time I deployed with the Jupyter Lab. So this is what you see when you enter Jupyter Lab. So how you access Nextcloud in your deployment? So we have mounted a virtual file system with your Nextcloud data in /storage. So as you can see, this information is all these files are the same ones that I'm seeing here. So this storage is automatically synced. So if I create a demo file, hopefully I should see it. Well, it might take some time to refresh, but if I create a demo file in my storage, you eventually see it in your Nextcloud. So, well, I didn't create it right. No, let me. Yeah, I wasn't in my storage, right? Demo file. And at some point you should see it in your, okay, it's there. So, yep. So this is how you access your data set from inside your deployment. So once you have your data connected to your deployment and you have the AI module in your deployment, you can just deploy the DPaaS API. So the DPaaS here in this terminal, we have deployed the DPaaS API, and well, as I said earlier, this quick access endpoint is for the service you initially deployed. So in our case, it was Jupyter Lab. But if you go to the information, you will see that there are other endpoints that, well, along with information about your deployment, like the hardware, the resources you are running in, you have other endpoints that are available. So in this case, as we launch the API, we have an API endpoint available. So, and this is the same API we were getting earlier. So in this case, I'm just training a mock AI module. So it's not really, there's no really any AI behind it. It just mocks a training, but for the purposes of this demo, it works fine. So we are just selecting the number of training epochs, and as this is mock, we are not we don't need to select any other thing like optimizers or so on. So once we execute the training, you will see that some models have a monitor endpoint available. So that it allows some models allow to monitor your training with any monitor tool you might want. So in this case, this model supports TensorBoard, so you can see how the training progresses. So the accuracy improves as as the training progresses, and then the loss decreases as expected. So this allows you to monitor the training, because well it might take all trainings usually take between days and weeks. So you will monitoring via an UI is usually a good thing. In addition, you will be shown in further seminars how to also monitor probably how to save all the models to MLflow also. And well, if we go back to our training, so our Jupyter Lab instance, we see that this has created a new folder with our training data. So you will see that it has saved our TensorBoard statistics in this TensorBoard file, and also a final model with the model weights. So once you have it here, you could doing the same thing I did earlier, you can go to /storage and then create your and then copy paste your model to there, and then you would have it permanently saved into Nextcloud. Or, as I said earlier, you could also integrate this module with your MLflow with our MLflow server, and then have the models saved there. So there's multiple options. So this is all for the second kind of user, the ones who wants to retrain, and then there's a final one, which is the advanced user who develops a model. So as Borja is going to present that, I'm just going to do a quick glance of what this means. So in this case, an advanced user who develops a model just wants to make a deployment, just wants to deploy our custom AI4OS environment. And what this means, this is an environment that allows you that comes configured with a lot of AI frameworks. So let's say TensorFlow, PyTorch, and so on, and in different versions. So to be as wide as possible, and then lets you develop with any of your favorite tools. In this case, either VS Code or Jupyter Lab. So you would go the same and then create some password. And well, again, as the other modules, you can select your hardware, but developing a module is not very compute intensive, so we do not need to train on to use quite expensive, computationally intensive hardware. So again, this has deployed, so it might take some time to. So this means again that the container has deployed, but the service is taking can take a bit more to deploy. So I have already one development instance ready. So this is what you would see. So you have to input the password you selected during configuration, and then you will see this VS Code instance. So you can just start, or for those of you who are familiar with VS Code, you just create here a new file and you start coding. So you can also start from our AI modules template, and that is what Borja is going to explain later. So just as a final mention, so as you remember, Alvaro said that in the previous talk that we offer seamless GPU access. So the idea is that you can just, as I explained, the configuration, select how many GPUs you want and with which GPU models you want, and just to show you, this is a GPU deployment I have here, and this is what it would look like. So I have deployed one GPU, and then you see that it's a Tesla T4 with 15 gigabytes of RAM. So with this, you can perform your trainings faster and so on. And I think it's all from my side. So I'm happy to take questions if there are any.
Thank you, Ignacio. Thank you for very interesting live demo. So while looking for the question from the chat, from my perspective is how can access be requested to log into platform? We'll try it out.
Yes, so access, as Alvaro said, we are making an open call. So the idea is that new users, so if you are someone who wants to use the platform, please be part of this open call. So submit your proposal, and we will evaluate the most interesting ones, and then once you are selected, you will get a contact. You will get the support email for the platform, and well, once you are selected, you can follow the documentation we have to create your EGI check-in account. So this is the way.
Okay, and there is some obvious follow-up question. Okay, I would really like to use this platform. So is there a maximum number of GPUs that the user can request? How this looks like with the resources?
So in principle, the physical limit, I think, is as many GPUs as they fit in a node, which I think we have up nodes with up to eight GPUs, I believe so. But of course, most users are developing models with single GPUs. So most users don't use GPU parallelism. So in principle, we are using as default one GPU per deployment, and then you can make several deployments. So you will have access to more than one GPU.
Okay, thank you. And so, as an example, can Visual Studio deployment also run Jupyter notebooks?
Yes, so there's plugins to use Jupyter notebooks. So I'm not sure if they are already installed, but you could create some demo IPy notebook. And well, for those of you who have used a Jupyter notebook, so this is what Jupyter notebooks looks like in Visual Studio Code. So you can write here your code, and that's it. Yeah.
Okay, so thank you. I don't see any further questions on the chat. So thank you very much for this presentation again. And now we move to Borja Esteban Santis, that is MLOps engineer at the Karlsruhe Institute of Technology, KIT, in Germany. He's an experienced Python developer with experience in machine learning, testing frameworks, and web services. So I think a bit what will be discussed has been introduced already by Ignacio, but Borja, you can share your screen and start the presentation. Floor is yours.
Thank you, Marcin. Thank you, Ignacio, for the presentation. So
please put it in full mode in a slideshow on the right.
Yeah. Sorry, that's all right.
Thank you.
Sorry. So thank you again. So yeah, as Ignacio mentioned, I will explain now the advanced user cases where it's how to create your and develop your models between this framework. So our recommendation, or the way that we try to make this step simple for the users, is to use templates. So why? To create a model the users or developers needs to write a lot of code, and by using templates, we can provide already big part of the code that has to be implemented. We might provide to all the users consistent and uniformity, so that will help us as well to support when all the codes more or less look the same. That speeds up development times and reduce costs. As well, we will help users that they can follow best learning practices and code practices. It will reduce the number of errors and as well reducing development time. It will let the users to focus on what is important and forget about what's web services and all the part that is behind. A lot of times, scientists, they know a lot about their topic, but they don't know too much about web services, and we hope to provide the code that they are really need for that. And also, it's a great way to learn more things and to try things different that how one person is normally used to do. We offer, for the moment, 3 types of templates. The first one is what we call main template. It's something really basic. It basically includes minimal code that will help you to run and to deploy your service into the platform. We also offer a child module in case that you already have a module running the platform and you need to kind of customize your Docker, a Docker configuration or do some retraining, that you can use this child module. It will only provide a Docker configuration. And the last one, for those users that they really want to customize things and want to take advantage of full features that the framework will provide, we offer the advanced template, which, well, I will give you a small demo after. So, main features, it's about the main branch is, well, that we will provide some basic code. As well, we will provide some basic software testing, so you can check that when you integrate some code inside, that it's going to run before you are actually moving your code into the platform. So it's good to know that if you can test it in your computer, that when you deploy it to the framework, it will not fail and your users will not be happy. Pre-configure Jenkins CI/CD pipeline. So all the changes will, when you change automatically, we can provide you with tools to run this continuous integration and continuous development. So integration will automatically be tested and you can have reports about code quality and a lot of useful information. Utils to connect with a remote storage, as Ignacio already presented. Nextcloud, how to configure my storage. We will provide some utils to make, or we provide some utils to make your life easy. AI application metadata as well, the same. So you don't have to worry too much. You only fill some basic features on kind of form, and all that will be customized inside the code. So you don't have to type everything by hand about what is in multiple places, what's your code or your model about, and of course, Docker containerization to run your service in the platform. So those are the main features that at least we need whenever we want to run something into our platform. This is an example of how it looks like, the project. So at the left, we have the main template and some of the files that we will have inside. It looks really, it's really a best practice Python project with or API files on how can you configure your Python project. And at the right, well, something really basic with a Docker file to just run the type template configuration. Now, with the time, users will get more experience. We hope that they will enjoy your platform, and then we understand that they will want to take the best of our platform. And for that, we offer the advanced template, where we will offer documentation generation for the API, more complex testing with PyTest, so everything can be better tested. Customization of arguments, so when they run will run the service, maybe they will start to want to configure which are the arguments that their API is going to accept. So maybe they will want different type of files, or they will want to have a more some kind of configuration on the epochs, or how the trainings or the predictions are going to be run. Basic files, so they can configure the CI/CD pipelines, and as well basic logging and use of HTTP response, so you can debug and to debug your application or your service easier. So these are some of the advantages in a more explained way. So, for example, we will allow, or we are defining multiple ways of how to integrate your code into the framework. We will see some of the different differences, but basically you can start your code from zero. So you're the owner of your code, and you want to just extend the API, that you can just integrate from model-based template. Maybe you have a submodule that you want to integrate, or maybe you just want to implement an API. I will go into this after. Additional context features, template response PDF, schemas modules for parameters to have additional argument inputs, pre-made testing, debugging, Jenkins, and more to come. Like as Ignacio was already mentioning, we want to integrate forwards or data version control with DVC. Into the details, for example, speaking of multiple integration modes, now there are three cases I was just mentioning. The first case, imagine that you are the completely owner of the code, and you want to integrate the API, so you know already how your model is working because you are the developer. Then you can run this wave one, and then the template will prepare these template files which you can customize and have your model running, so you can have your modules with the prediction and train functions, which will be called by the API. Now imagine that you are not the owner of the code, but that code, maybe it's a former colleague from your organization, or is another person who is focused on the specific technical topic. So you are not the owner, or you don't know too much about how to modify, how to support that code, or is in a different repository in your organization. Then we offer the option to integrate it as a submodule. So imagine that you are the API, you want to provide the API and you need the source code, then you can add the repository as a submodule into this new API repository. And then all the tools will be integrated and you don't have to worry about touching the code of the model developer, then without any part to break it. Another option that we have seen from the users is sometimes they just want to use popular models from like YOLO 8 or 9. For example, in this case, yes, the users don't expect to have the model code inside the service itself. So it's also possible to just generate an API, and therefore you can just offer API service to some kind of already published or popular solution for the code. Additional code features. So I was explaining we can customize schemas. So in the case that you want a really detailed or customized for a specific application, special parameter to have special parameters or arguments to run your predictions, then you can extend in a really Pythonic way or a standard web services way, especially using Marshmallow schemas. Then users might easily modify how it looks. We'll check a bit later on that after. Additional code feature. So this is how it will look, for example, when you are running tests in VS Code, then you can ensure easily or check just with so few clicks what is failing in your service, and then go easy to fix or to patch that small mistake. And also will help you in case that in the future you want to add more features to ensure that nothing is breaking when you have developed before. Sometimes you want to add a new feature and accidentally you modify something and that small maybe breaks, I don't know, another part of the code. So you want really to make sure that when you deliver your changes into your service, everything is still running as expected. And well, Jenkins server quality baseline. So you can run CI/CD pipelines automatically. The files are already there. So you just have to focus on the code, and then you can access every time that the user commits something, you can check that that commit actually is generating quality code and nothing is breaking in your software. And more to come, we want to provide data version control support. So you will not only data version your code, but you can also data version your data. So you might actually work with different branches of data in case that you want to do different testings of model configurations or trainings. And we also want to implement automatic drift detection with forwards. So when you run your CAD pipeline, and you maybe put new data into new training, or you put new data and you want to train it with new data before the new generated model is deployed to service, then you can automatically get notifications if there is a drift on data or a drift in the concept. So how can you start? So we offer a web service with at least with the 3 templates that we already mentioned. Here is the link that you can access with the QR code, and well, we will see in the demo. But basically, you can choose any of these 3 templates and generate the code to start with. This service is powered by Cookie Cutter. So maybe if you have already used Python, you already know about it, but basically it's really easy. It will just ask you about some questions in a type of form, and then it will allow you to customize the project that is going to be generated. Of course, you can use the web service mentioned before. You can also run the command line directly. I put here some of the links of the templates in case that you want to take a look into them. The source links are going into the web service, so you can automatically you can also access directly to the source code in GitHub. And now that we still have 15 minutes, I would like to make a small demonstration of how this works. So to do so, I will just exit my screen from this mode. Let me know if you can see my browser. Ready? Okay. Then this is the website. We have the 3 options, and of course we can click on the first option, and then we will have a form with some fields that we can complete with what we want for a project. I already took the step, and I already have here all the form completed, so we can just generate one of the files. So if I click on generate, then the generation process will start, and then I can just access my generated, and I can download the project in a zip compressed format. If I go to downloads, then I already unzipped the project. Can you see my downloads folder? I hope. No, okay, I will share my screen. Yeah, and well, we can see the files are already generated inside. So for example, we have all the files that we need to run all the features in the framework. The next step will be to open those files with Visual Studio Code, for example, and to start to customize the application. As is explained in the documentation, once we open VS Code, one of the first things that we have to do is to install the packets or generate project. So to do so, we normally will run pip install in editable mode. And then I already pre-installed the packages, so it should not take too much time. It's only validating the things, yeah. And now the package installed is ready to be running. So for example, this advanced template already includes a lot of files to already run easily with VS Code. So for example, we can run the debugger, and we can select to run the deep as a service code, and then just click on the play. The terminal will open. We can now open the browser, open it in the editor. We go to the user interface, for example, and then here we can see in the local host, the application already running, and we can try it. We see that, for example, all the endpoints are generated, so we can, for example, run the to get the metadata, as Ignacio was just trained. This is running. And we can already also debug. So for example, we can just try to make some predictions. For example, some model, so we can choose a file. For example, the background, it's going to fail, of course. But that's the interesting thing about it. When you are running your local host, you can actually run the debugger, and it will stop in the line that is actually failing. So you can just modify it. And I don't know, for example, this, you don't want to write this, but then it will rise in another place. And then you can just write it. Now run. Yeah. Well, now, yeah, it's failing because it says that there is an if statement which was not expected, of course. But well, yeah, not too more delay into that. Also, it zips, as I mentioned, with testing. To run testing in your computer, you can use Tox, which will automatically prepare Python environments. Or if you want to do it with VS Code, there is a README already explaining the important points, but basically you need to run or to install the requirements for testing. So we can just copy this command. All the tools for testing will be installed, and then to the left, well, we can just check, because I just break it here. It will fail. We can see why it's not failing. Now, for example, all the tests are corrected here, and we can just simply run all the tests and see what's not working in the system. Sometimes it will take more time than the other times. If not, we can just, if it's now it seems like it's starting or having the service. If it takes too long, maybe because one of the tests is failing for some reason, we can just stop and try to run different parts of the code with. Well, okay, meanwhile, it's testing. Yeah, so it passed. And yeah, that's it for the development. There are all the instructions in the README. And yes, I think. And the last step, of course, once you know that everything is working and running, will be to upload the source control. You can just directly put here the changes and upload them into the repository you are working with. And once it is in the repository, then you can go to the AI4EOSC hub and then add your repository to the catalog. The instructions, well, also you can access the Jenkins pipeline about the models into the catalog. So everything is, as I mentioned already, everything testing. So for example, here I have this demo stance, which is showing that everything in the process of building is correct. And here in the documentation, as Ignacio already mentioned before, well, you have all the steps for the advanced module of how you can, setting the framework, edit the files, or integrating model in the AI4EOSC marketplace. And with this, I think that's everything, and I will leave some time for questions.
Okay, Borja, thank you very much for this comprehensive demonstrations that shows some more advanced features of the platform. So now maybe we can go to the questions. So while waiting for the question from the chat, is just one thing came to my mind. So if I would like to start working with, are there any examples that can be followed to consult the usage of the templates?
So in the hub, there are a lot of repositories are really working. Another option. So if we go directly to the AI4 hub, you can open any of the repositories here and see how other people are implementing their projects. We officially provide some demos. So you can filter here. In this case, we offer a demo for Demo Advanced. And this is a full working demo with all the features that you might expect running in the framework. So for example, we have data already loaded with MNIST images and examples of how you can run or to generate different models and encoders, for example, how you can configure the environment, how you can test. So all the files are really in high quality basis. And yes, you can copy just directly the code if you like some of the ideas, or you can modify them. The example is in this specific example is using TensorFlow, but there are other models which might be using PyTorch.
Okay, thank you. So there's another question from the audience. So what has been demonstrated? So will this work once the marketplace is offline? I'm not sure, however, on which marketplace it was the question, if this is about the EOS marketplace or the model marketplace here, AI marketplace. So can you please try to address this question?
I'm not sure if I understand. Because the marketplace, it's about the project of AI4 EOSC. What is going to be in the marketplace? It's probably the question is something more related about a specific service, which maybe one person would like to put it into marketplace.
Yeah, maybe Alvaro, you can address this question.
Yes, so the modules that are contributed here are stored as code repositories in the end, openly in any Git, let's say, enabled platform like GitHub or GitLab, or even a private GitLab instance. The artifacts that we are building are available currently in Docker Hub and in our own container registry. And the modules can be executed standalone regardless of the platform. So you can download a module in your laptop and execute it. Obviously, our web page and marketplace is linked with the platform, with the underlying platform, allowing you to execute the modules in the underlying resources coming from these EU cloud infrastructures.
So and here the questions was actually I have just now follow up that this is about EOS marketplace. If whole this platform will work without EOS marketplace.
Yes. What has been shown here is our own model marketplace. We have integrated with the EOS marketplace so that the users can find us more easily. Users coming from the EOS realm, let's say, but it is not a dependency from us on the marketplace itself.
Okay, thank you very much. So looking further for the question, so I don't see in chat, but so final question from me to Borja. So can I create and use my own templates?
So templates related with AI4EOSC are in this specific server, which I already offer. Of course, you can create your templates using cookie cutter and run them. If you want to publish your template in a service where other users might use it to generate it, because you would like to be displayed in this form, like we have a similar service at templates, services, well, we have another service called template services where, yeah, we are open to generate or to have to host other users' templates. So this specific URL or templates is only for AI4EOSC templates, but we have another where, yes, users can actually create and publish their own templates.
So Borja, thank you again for this presentation, and I would like to thank again to all the speakers that were presenting during this session. We would like to thank also all the participants for being us with here till the end, and I would like to remind about the next webinar again, that is 8th of April. And just kind reminder about our open call, so you could consider about applying to the call. So with that, I think we are just in time to finish our today's workshop and webinar. Alvaro, I don't know if you have any final word or we finish now.
No, I just wanted to thank all the participants to this webinar, both the speakers and the audience, and just stay aware that because we will be announcing this open call in the next days. So we hope that this was interesting for you and that you apply for this open call so that we can bring you on board as a new use case of our project and support your research.
Okay, thank you again. And with that, we finish today's webinar. Bye-bye.
Bye-bye.